All right, so this one you may have already done if you've been on 5.5. So, okay, use properties of logs to find the exact value. All right, so we're talking about, I don't know if he wrote out or if you remember, there's basically three, that's the weirdest thing. My pen's not working again. I just tested it this morning already. So strange. Anyway, okay. So I'm writing with my finger again. There's basically three log properties. Did you get those? Number one, basically the log, or did I write these out before? I just can't remember. Log base b of x times y, that's a times in the middle there, is the log base b of x plus the log base b of y. Multiplying for one log becomes adding for two. Okay, and then number two. Whoops, erase that. Number two. Dividing for one log becomes subtraction for two. Right? You've seen these? Remember these kind of a little bit? Remember these from your algebra days? That multiplying for one log is adding for two, dividing for one log is subtracting for two. The thing that's not changing up there is the base b, so don't even worry about that. They're all log base b. The only thing that's kind of moving around is the x and the y, huh? So multiplying for one log is adding for two, dividing for one log is subtracting for two. The way, one of the ways I remember it is basically the easier operation is for the two logs, the harder is for the one log. So in other words, you know when you're first in school, what's the first operation you ever learned when you were a young child? In math, I mean. Adding, right? Didn't we start with adding and then subtracting? Wasn't math easy in those days, right? Those were the days. Then you moved on to multiplying. I still remember 4th grade, Mrs. Unmack's class, being scared. I had to go up to her front desk. Everybody had to go up to the front desk and say your times tables to Mrs. Unmack. 4th grade. Anyway, that was math started getting more scary and harder. Multiplying, dividing, right? Well, it's so thinking about it that way, adding, subtracting are lower level, multiplying, dividing are harder. Notice the harder job, multiplying or dividing, is for one log. The easier is for two logs, adding or subtracting. So it's kind of like how the old saying, you know, many hands make the job lighter, whatever. However, basically, more people make the job easier, right? So more logs, easier job. That's an easy way to remember all these properties, right? One log, it's a hard job, multiplying. Two logs, it becomes easier. You make it two logs, just adding. One log, it's a harder job, dividing. Two logs makes it easier, just subtraction. And it makes sense that dividing would go with subtraction. They both make things smaller, right? And adding and multiplying would go together. They both make things bigger, right? So that's just a way to help you remember that. And then number three, the third one, log base b of x to a power equals, anybody know this one? What can that power do? It comes down to the front. That's the greatest quality of the log right there. It comes down to the front. If I can squeeze it in here. There it is. So let me separate 2 from 3 there. That's it. That's the whole property. That's a smaller one. It just brings that power down. So it takes powers on an argument and brings them down to the front. That's actually a really, really big deal. We'll see how useful that is for solving all kinds of exponential equations, basically. So there we go. Those are the 3 log qualities. The one they want me to use on this particular question is actually the third one. So they want me to take that 29 and just bring it on down. So I can grab that 29 and go, okay, you come on down to the front. Maybe I better, if you guys got that copied down, I'll go on to a new screen here. And we'll just do that third quality there. All right, so log base 3 of 3 to the 29. Just bring that on down there. So 29 log base 3 of 3. Good to there so far? That's what the third quality said. It's kind of surprising. The powers can actually just drop down like that. Okay, now, what do we do now? What's log, what is this part? What's We got the 29. Sure, that's good. But what's log base 3 of 3? Yeah, it's 1. Do you realize that's 1? Remember how we talked about when you have log of a weird base, when I say weird base, I mean a base that's not 10 or e. You let the high go high and the low go low, which that's clearly 1, huh? So this is 29 times log 3 over log 3. So it's 29 times 1. It's just 29. Make sense? Remember how the high goes high and the low goes low when you have really any base like that. So there we go. So the answer to that problem is 29. I didn't even need to use a calculator, although you could have just done it on a calculator too. Good to that? Everybody good there? All right. So let's. Okay, so the trick on this one is to remember. Oops, is it on the screen now? Yeah. Is to remember. So let me just write it a little bigger. Natural log of e to the minus 25. The trick is. The way it's written, notice that there's not a lower down base number there. Now, you might say, well, that e, there's actually another e, is the trick. How do I know? Because that e's on the level, there must be another e like there. How do I know that? Because there always is, for every log, regular log, natural log, any log, there's always a base number. There's always a lower, remember, base just means bottom, like baseboards, right? So there's always a lower down number. So if they're not showing a lower down number, you've got to put one e in, even if that means putting in another e. Because for ln, it's e. If it was regular log, what would be the low down number if it wasn't showing? 10, right? So you put it in there. Even if that means doubling up the e's, it's still got to be the case. This e is just on the level. He's not the base. Okay, anyway, so what? Okay, great, so what? Well, now let's do the same thing we did the last problem. Take that power and bring it down there. Right, that's the third property of every log. Any kind of log, natural log, regular log, whatever. They all have that quality, those three qualities. Power comes down. And then what is this going to be? That part's 1. Because again, it's, remember, you'd let the high go high and the low go low, and it's ln e over ln e. It's 1. So the answer is just negative 25. Didn't even need a calculator. Make sense on that? So power comes down to the front. Put in the missing e, and high goes high, low goes low. Negative 25. So let me see. I'll try to go a little quicker then. 7 to the log base 7 of 6. Yeah, that's 6. The answer is 6. I always have a little trouble explaining why without getting too wordy and too detailed. Let me say two things. Let me say simply, when the base matches the power, you can cancel them out and the answer is just 6. Now that's not really a lot of logic. That's just, hey, here's something to remember. That'll always be the case. When the base and the power match, you can cancel them, because what logs are is reverse of powers. So they'll cancel and the answer is just 6. Now, why is that the case? What did he give you? How did he do it?
He gave us, it's a, and then log a to the x.
Yeah, so he said a log a of b or whatever. Right. It's just b. Yeah, so he's just saying what I'm saying with letters instead of numbers. Yeah, but that's still not logic. That's still like, why do those a's cancel? Why do, in my case, why do the 7s cancel? I'm just saying they do. I'm not giving you like reasons based upon what you already know. All right, it's because it's a little tricky, and I'm always afraid to use up too much time. So let me say it kind of quickly, and we'll just leave it at that. When you write log base 7 of 6, wait, is that a good way to do it? I don't know how to do it nicely. Let me. I'll take a shot at it. There's several ways. I'm not sure the best way. So let me do it this way. Let's just grab that power, just the power, which is log base 7 of 6. Let's just call that x. I'm just going to give it a name. I'm just going to prove to you what I say is true here. Let's just give it a name, x. Call it Joe. Call it y. Whatever. I'm just saying whatever. So this is 7 to the x then, right? Because I called x log base 7 of 6. Good so far? So whatever 7 to the x is, that's our answer. Because I've called that power thing by the name x. So far, so good? I'm just giving it a name so I can fiddle with it, right? So I just said, hey, power, you're called x now. I'm going to do some manipulations with you. But let's remember, that makes the original question 7 to the x. All right. So what is x? Well, remember what we learned. I want to show you in terms of what we've already learned, that we're not doing something new here. Remember what we learned about when you lose the log? What happens? Base stays the base. Other two switch, right? So the 7 would stay the base, and these two would switch. Instead of 7 to 6, it'd be 7 to the x. 6 go over there, right? So what is 7 to the x equal? 6. So what is x? X is the whole power thing. So our answer is 6. Did that help at all? Am I losing you? In other words, somebody said, what do you mean, Mr. Aaron? Let me do it one more time. What was the original question? 7 to the log base 7 to 6, right? But what is log base? What is this power? According to this, it's just x. So, and what is 7 to the 6? According to this, it's just 6. See? It's true. Based upon what we already know. All right, so I don't know if you like that better or worse. There's the proof. And so just cancel when the base and the power match, cancel. There's y. All right, so log base 12 of 6 plus log base 12 of 2. All right, there we go. So we're supposed to add those. So what's the rule there? What do they want me to do? They say use the properties to find the value. Okay. So what did we learn? Remember the property that said adding for 2 logs. An easier job for 2 logs is multiplying for 1 log. Right? Remember that first property? It said easier. Same base. They got to be the same base. They are. They're both log base 12. We don't mess with the base. We just take the 6 and the 2, the arguments, the plug-ins to the toaster. And we say adding for 2, easier job for 2 logs is a harder job times for 1 log. And then, okay, great, so what? Well, then that's log base 12 of 12, isn't it? And that is 1, because they match. Right? We good on all that? Questions? So let's take a look here. All right, so subtraction for 2 logs, divide for 1, right? Easier operation, right? For 2 logs, subtraction for 2, easier. Same base, the bases match, so that's all good. So then it becomes divide. That's supposed to be an 8 up there. It's supposed to be divide. That's not a 0.8. I'm just scribbling. Divide, harder job for 1 log, right? So that's log base 4 of 4 then, which you know is 1. Good? Easy, you guys are like, okay, so what are we supposed to do with that? Well, what I'm going to do is I'm going to turn them into the 2 logs. Remember the high goes high and the low goes low? Whoops, not like that. Remember how we can always turn 1 log into 2? Yeah, I hope I'm not confusing you. I probably should slow down. There's 2 properties that I'm referring to. Well, there's 2 classes of properties. So there's those 3 properties that I just wrote on the screen a minute ago, right? Property 1, 2, and 3. There's earlier property. Remember the earlier property that said if you have the log base b of y or x or whatever, you can always make it log y over log b, right? So I hope you don't confuse that property with the other 3. You see what's going on there? So we have those 3 that I just wrote a minute ago that said adding becomes multiplying, subtraction becomes divide, right, and powers come to the front. There's those 3. And then there's this one that we had, a week ago, 2 weeks ago, where, the high goes high and the low goes low, right? 1 log can turn into 2. All right, so keep all those together. So looking at this question, right away I'm going to go, okay, look, I'm going to do the high goes high, the low goes low, times, and the other side, the high goes high, 256, over the low goes low. Everybody good to there? High goes high, low goes low, high goes high, low goes low, and then what? Boom, boom, those will cancel, huh? See that? It's just cross-canceling fractions at that point. And then I would just hit the buttons on my calculator for what remains. Just log 256 over log 4. I'll just say calculator. And I think it's, is it 3? 4. I think it's 4. 4? Yeah, just hit the buttons on your calculator and divide those. Log 256 divided by log 4, you'll get 4. The log 5's canceled out. But you don't have to, huh? You could have just hit the whole thing in your calculator if you wanted to.
Anna, do not use the calculator question in school.
Oh, it's okay. I'm not gonna put that on the no calculator part. And you always have some kind of calculator. Yeah. So yeah. All right. That's right. Yeah. I could show you how to figure that out, but we don't have time for all that. It's basically saying 4 to what power is 256. Anyway, I'm tempted. We don't have calculus. You know what it is? It's like we're in advanced algebra. You know how there was basic algebra, there was intermediate algebra. That's pre-calculus is basically advanced algebra, right? Because we're doing what you did in intermediate algebra. Look, they're making it ugly and fancy, aren't they? It's like advanced algebra. They're doing logs and they're doing them kind of messy. Okay, so how are we going to do that? I'm kind of stalling because I don't know as I look at it. What is that?
Use the quotient property.
Oh, yeah. Good job, Robert. Thank you. Right. So up in the power zone, subtraction, huh? So that'll become dividing. So right. So log base, they're both log base 6, so that'll be 8 over 3. Good so far. I took the 2 logs in the power, made it 1 log. Subtraction for 2 logs becomes a harder job, dividing for 1 log. They have the same base. They're both log base 6. Good so far. I didn't do anything with the base 6. That's still there. So far, so good. And now, remember when the base and the log match, just cancel them out? 8/3. Remember how we learned that? And the reason is because logs are opposites of powers. That's what they really are. They're opposites. And we saw that last week. Last Monday, was it? How they're inverse of logs were exponential graphs. Remember those problems? Good. Questions on that? All right, so log base 7, 343x. Okay, so they want us to write as a sum or difference of logs. So basically, we're going to make this 2 log base 7s, aren't we? And the harder operation of times is what's currently there becomes adding. There it is for 2 logs. We're done. So we made it into a sum and adding of 2 logs. Right? So multiplying for 1 log becomes adding for 2. Is that good? Questions on that? So again, the harder operation for 1 log times easier for 2. Adding. Same base. The base doesn't change. Same base on that. All right, so natural log, and we have x to the 8th and root of 7 minus x. Those are times, really, in there, as you know, huh? Those are multiplied. So basically, first thing is we can make it 2 logs added. So far, so good. Because multiply, harder operation for 1 log, is easier, adding for 2. Everybody good so far? And now, what did we learn about powers? Powers can come down to the front, so that 8 can slide down to the front. Hey, what about the root? So this one's going to be 8 ln x. That one's good. But what do we do with that other part with the root? Good. Yeah. Do you guys know? So they're going to test you on this on several problems. So let's just get this really clear right now. Do you remember fractional powers? Let me remind you. So this is like advanced algebra again. You basically done it, but they're really going to push you harder than you're used to being pushed on it, I think. Do you remember like what x to the, I don't know if I have room right there, let me go over here. X to the a over b, like fractional power. Do you remember what that means? Remember how the b swings around and goes in the hook? It's the bth root of x to the a. Do you remember what I'm talking about? Remember that? Remember fractional powers mean the denominator swings around into the hook. Anytime you need to, you can change from fraction power form to root form, or vice versa. And sometimes it's easier to work with fraction powers, especially in calculus. It'll be a lot easier when you do derivatives. Fraction powers are easier than roots. They'll give you root problems, and I always tell my calc students when I do teach calc, is I say, change it to fraction powers. It's easier to do the rules that way. So anyway, all the time in math, we can change forms depending on what we're trying to do, which form would be easier for that problem. So those are the same things. So what? So then what is x to the half power, for example? Well, using the same rule, the denominator swings around. The numerator stays put. Just like the a stayed put, it didn't go anywhere. But the denominator swings around, so the 2 will swing around. It's the 2 root of x to the 1. But both of those are understood. That's just root of x, huh? Because if you just write root of x, the 2 is understood to be in the hook, and the 1 power is also automatically understood. So my point is, anything X or Joe or Tom or W to the half power is X or Joe or Tom or W to the root, or a root of it, I mean. So a root of something is that thing to the half power, isn't it? So that's what they want you to see. Right here, when you see this root, down here you can go, oh, I know their trickery. That's the root of that thing is that thing to the half power. So what? And then the half power comes down. That's what they're going to want you to do all the time with logs. When they got a root on something, they're going to want you to say, oh, that's a half power, and powers come to the front. So the half comes to the front, ln 7 minus x, all done. See how they say express powers as factors? Factor means multiplied things, so take powers and bring them out front multiplied. That's what they're saying. This is the answer they want. Is that good?
0 to 7 effective?
What's that? Oh, yeah, no, you don't have to do anything with that. They're doing that because that's the only part in the domain. Meaning, you don't have to do anything with it. But they're just being super careful. If you put in something bigger than 7, like 8, see how it would make the inside of that root negative? 7 minus 8 would be negative 1 inside the root, and that's not allowed. They're just, you don't have to do anything with it. They're just being careful. Yeah. Good question. Okay, so basically I'm going to make these into 2 logs. Log base 7 of x to the 15th minus log base 7 of x minus 3. Right? Right? Dividing for 1 log becomes subtraction for 2. Easier operation for 2. Power comes down to the front. You do, by the way, you do need parentheses. Because otherwise, if you don't put the parentheses, it means only, it's only like, if you don't put the parentheses, what that technically means in the math world, it's not just Math Excel being picky, it's technically wrong. It means log base 7 and then like 3 is subtracted afterwards, outside of the log. And that's not what you mean to say, huh? You mean to say that 3 is part of the log, it's plugged into the log, so you have to put parentheses to say that's in the toaster. That's in the log function, the x minus 3. So Math Excel will mark that wrong, and they should. On the test, I'm not picky with that kind of thing, but Math Excel will be. Is that good? Does that make sense? Questions on that? Okay. I think a little easier than some of those earlier ones. All right, so I'm just going to basically break it into 3 things. The stuff that's multiplied on the top becomes added, right? The x and the x plus 6. So it's going to be 3 logs. So it's going to be log x plus log x plus 6. And I do have to parenthesize that, so I know it's all plugged into the toaster. Minus log x plus 5. And the 9 will come to the front. Done. Is that okay? I just do that in one. Sometimes it's easier just to do one step. Right? So the things multiplied became added, right? And the thing divided became subtracted, and the 9 came to the front of that log. Hey, those logs are not showing their base. We don't have to write anything in, but it just means they're base 10. So, but you don't have to write that. Just like that's fine. But you do need the parentheses on these guys. That is required. All right. Okay, so let's, first thing I'm going to do then is take that 1/3 down. 1/3 ln. Now that top is factorable. It's x minus 3, x plus 2. I don't know if you've noticed that. So, factoring that top, right, because the sign in the middle is -1. Right, -1 right there. So the sign on the bigger is negative. Remember that? When you're factoring, sign in the middle goes on the bigger, goes on the 3 instead of the 2. Negative in the middle, negative on 3. Anyway, so what? Well, now I can just break that into 3. That 1/3 will be in front of everybody. It'll actually become 2/3 in front of the bottom one. So 1/3 ln of x minus 3 plus 1/3 ln of x plus 2 minus 2/3 ln of x plus 5. We're done. So here's our answer. Do you see, everybody see why that 1/3 went to everybody? Because the 1/3 was in front of the whole log. So when you break it into 3, it's going to distribute to everybody. And the power 2 came in front to make it 2/3 on the last one. And the last one's subtracted because it's divided, huh? And the first two are added because they're in the top, they're multiplied. Is that making sense? So you guys getting the hang of that rule. Basically, let me put it to you as simply as I can. Anything in the numerator of a fraction, anything in the top, is going to end up added logs. Because they're multiplied, huh? Things in the top are multiplied. Remember, multiplying goes with added. Right? So anything in the top is going to be become added when you break them into several logs. And anything in the denominator will end up subtracted. Even if there's several things, they're about to do that to us. They're going to put like a couple of things in the denominator, and you might think, well, they're multiplied down there. Multiplied should be added. Well, when you're multiplied in the denominator, you're really divided. And so they're all going to become subtracted. So simply put, denominator, subtraction, because that means divided. And numerator, added logs, because that means multiplied. That's always the rule when you break them into several logs. All right, so I'm just going to try to do that one in one step if I can. ln of 2x plus ln of the root of 1 plus 4x minus 4 ln of x minus 6. And then I can do the root thing also. Good so far? I'm going to also do this root, as you know, is a half power. So just bring that half power in the front, huh? So just stick a half here. Everybody good with that? And then just get rid of the root. Everybody see what happened there? So there's our answer. Is that good? Does that make sense? There's something small wrong with it, but it's generally right. Everybody agree that it's generally the right thing, right? The things in the top, the 2x and the root of 1 plus 4x are added. The thing in the bottom is subtracted. The powers came to the front. The root is a half power in the front, and the fourth power is now in the front as well. So it's generally right. What small little detail is wrong with it?
The 2x?
What's wrong with the 2x?
Couldn't you break it apart again?
You could. I don't think they're going to make you, but you're right. You can make it ln 2 plus ln x. That's true. I wonder if they'll be that picky. Maybe they will. You're right, though. You're totally right, Tim, and whoever else said that. If you wanted to do it like that, that would be... I'd be fine either way in the test. That's true. Or you could just leave it. I think Math Excel will let you leave it as well. But so that's your good point. So aside from that, I'm fine either way on a test. I think Math Excel is fine either way also. But even beyond that, there's something else. The what's that? Good. Need the parentheses on the 1 plus 4x. Because remember I said, if you have more than one item plugged into the toaster, you've got to show that that's all in the toaster. Otherwise, it means only the first thing, nothing else. And that's not what we mean. Is it 100% right now? There's actually one other tiny, tiny thing. You also need parentheses there. Or it means only the 2 is plugged into the toaster and the x is outside. It doesn't look that way to our eyes, huh? We just see them so close. We're like, hey, they're together. But technically, Math Excel is probably going to want you to put parentheses around it. So that makes sense. Anything plugged in, if it's more than one thing, it's got to have parentheses. Otherwise, it means only the first item is plugged in. And we mean both the 2 and the x are plugged in. All right, yeah, good. So now it's 100%. Correct. Math Excel will take it. Okay, so 3 log 5u plus 9 log 5v. So they want us to make it a single log. Make it one log. So you guys know how to do that. Log base 5, u to the 3rd times v to the 9th. Done, huh? Just crunch them together. Adding becomes multiply. Powers go back. Front numbers go back to the power. I made it one log. Single log. It's a harder operation for one log. It's times. Harder job for one log. Easier just adding for 2. Right? See the way the properties work? We good? Okay. So they want me to crunch these into one log. So here we go. Log base 3. Now it's subtraction in the middle. So what does that mean? It's going to, when it becomes one log, going to be divide, right? Exactly. So root x over x to the 6. Good so far, right? Subtraction. Easier job for 2 logs. Subtraction becomes harder for 1 log dividing. Okay, now what is that root x? Well, you know, root x is x to the half power, right? Anything with a root is a half power. Okay, so what? Now what do we do? Well, you guys know. You tell me, what if you had x to the 3rd over x to the 7th? Remember your algebra rules? What would that become? 1 over x to the 4th. Remember, you subtract powers, and wherever the bigger one is, that's where the answer is. So the bigger's on the bottom, the answer's on the bottom. Remember those power rules? You see how they're taking algebra and they're putting it on steroids here? It's algebra advanced, right? You know these rules, but they're really making you use them in uglier and uglier situations, getting you ready for calculus, basically. So you know that, but now that's what you got to do here with fractions. So you got to take 6 minus a half. What's 6 take away a half? 5.5. Yeah, that's how I think too. It's 5.5. Now they can't leave it 5.5. They don't want mixed numbers. So you know how to convert that though, right? Multiply and add. 5 times 2 is 10. Add 1 is 11. So it's log base 3 of 1 over x to the 11 halves. And we're done. Is that good? See what I did? I just multiplied 5 times 2, 10. Add 1. Make it 11 halves, right? 6 take away half, 5.5. So there it is. We made it 1 log. Tim?
Math Excel, they want you to put the 11 halves in front of the log and make it negative.
Express. Oh, you're right. I didn't even notice that. Thank you, Tim. So let's do that. I didn't read the rest of the words. Yeah, see how they're saying that? Well, I don't want to underline things I'll mess up. I'm going to go to a fresh page. Everybody good to there? We have one more step then. I'm glad you called my attention to that. So far, so good. We have log base 3 of 1 over x to the 11 halves, right? That's where we were. Yeah, you're right. I should have read the words. It says express powers as factors. That means powers they want in the front multiplied. Factor means multiplied. So, yeah. So you know that is the same as log base 3 of x to the minus 11 halves, do you? A negative power is what makes it flip and become a fraction, 1 over x to the 11 halves, and then, yeah, power goes to the front. So it's negative 11 halves log base 3 of x. Good. All well there? So they're pushing on all those algebra rules, aren't they? Roots, fractional powers, negative powers, subtracting powers. They're making you a master because that's what you got to do in calculus. Okay, so subtraction for 2 logs. Well, first off, I got to take that 6 and put him up there. And then subtract. So log base 4 of x squared minus 25 over x plus 5 to the 6th. So far, so good. Like that. Right, subtraction becomes dividing, right? And now, am I just done right there? Almost. What can I do? Yeah, that top is factorable. It's x plus 5, x plus 5. What if that had been x plus 25 up there? Yeah, that's not factorable. Remember, that's like my mantra of the whole semester so far, huh? I just keep saying, double added, can't do it. But with subtraction, yeah, we can do it. We need to, because then we get that, and so one of these cancels one of these, and that's 5th power. And there's our final answer. I just leave it like that. That's our answer. Does that make sense? Roberto, do they erase your hours again?
Probably do.
Okay, big weekend. Let's erase the tutor's hours. All right. Good to there? Is that okay? That's where you guys got to, right? 17 or something? Okay, so we have 2 logs added, 1 subtracted. So what does that mean? They want me to combine them all into a single log, right? So here we go. Basically, anything added, so remember the basic principle. Anything added becomes multiplied. Anything subtracted becomes divided, but an easier way to think about dividing is denominator. When you put something in the denominator, that means you're dividing it. So let that thought make life easier for you. So here's what I'm talking about. I'm just going to take x over x minus 3 times the x plus 3 over the x. See why I did that? I just multiplied that x plus 3 over x because it was added there, right? And then keep going. Now, what about the minus guy here? Well, that means x squared minus 9 will go in the denominator, and I'll factor it in a minute. But you see how I made that into one log right off the bat? And the added log, I just multiplied that straight. And then the subtracted, I stuck it in the denominator, because that's what subtraction means. Divide, denominator. Right? And then, I can cancel these x's right now. And I can factor this part, as you know, x plus 3, x minus 3, and then these cancel, don't they? So I get to there. And then, oh yeah, this is going to be, so bringing it up here, there's another step here. It's going to be ln then of 1 over x minus 3 squared, huh? Which I can do some fancy stuff with that. Is that good to there so far? Right? See how we have 2x minus 3's left on the bottom? Nothing on the top, so it's 1 over x minus 3 squared. And then, isn't that ln of x minus 3 to the negative 2? Right? Remember, flipped is a negative power. So see how they're really pushing you in all these rules. You got to know them. You got to know all these rules. It takes practice. Negative powers, fractional powers, roots, right? So that's negative 2, and then that power comes to the front. Negative 2 ln of x minus 3. There we go. Is that good? So whenever I see a fraction like that, I make it into a negative power, don't I? Because that's what a negative power means. Flip it. Right? Is that good? All right, so they want me to make it one log. What should I do? I'm going to take that power and put it up there right away. So I'm going to get log base 5. 6x minus 1 to the half power times 8 is going to be 4. Minus log base 5 of 8 over x plus log base 5 of 8. So far, so good. Am I going too quick? See what happened there? So that root, 6x minus 1 root, is half power. Right? Root's half power. And the 8 in the front goes to the power. They're going to both be in the power, so they'll multiply. Powers with powers multiply. So it's going to be a half of 8. It's going to be 4. So this will become, on the next line, log base 5 of 6x minus 1 to the 4th over, oh, wait a minute. Okay, you're supposed to subtract this guy. Subtract. What does that mean? Divide. So I'm supposed to put 8 over x down there like that in the denominator. Remember what that does? Remember when you have a fraction in the bottom of a fraction that it flips up? So it's actually going to be x up here and 8 down there. It goes upside down. Does everybody see that? And then lastly, add with an 8. That means another 8 in the top because it was added. And then those 8s will cancel. Too fast? Did you see all those operations? So again, anything subtracted means that 8 over x is denominator, but another way to think of it is it's upside down. When you're in the denominator, you flip, right? You guys with me on that? Whenever you have a fraction in the bottom fraction, so I have 8 over x, it flipped x over 8. X over 8. Here it is right here. Everybody see that? X over 8. Right here is that, where that went. It flipped upside down. Why? Because it was subtracted. If it was added, it would just go straight. You know, the 8 would stay in the top, the x would stay in the bottom. But if it's subtracted, that means it's actually upside down. It's denominator on that. Another way you could say, here's what's nice, is you learn more and more and more deeper algebra rules. It actually starts to help it some. It's painful for a long time, but then it starts to help once you, because they start to agree with each other on a deeper level. Here's what I mean. Another way you can see that negative in the front, doesn't that mean a negative 1 really? Yeah, okay, so what? And so doesn't that mean negative 1 power? If you wanted to. I don't really want to do that, but it does mean that. Remember what we learned about logs? So what? What does a negative 1 power do to something? Flip it. See, that's another way to see, oh yeah, it's true. Subtraction is like a negative power when you move it up, which we already know flips things. So of course it takes that 8 over x and flips it to be x over 8, which is in agreement with what we already know about dividing by a fraction. It flips it. That's the deeper why. it flips it. So they all start to agree with each other. Question, Tim? Comments?
So in general, when you're dealing with a problem like this, whenever you're subtracting, that part of the log will go on the bottom, and whenever you're adding the part going
Exactly. So when you're doing this, any subtracted log, that part goes to the bottom. Any added log, that part goes to the top. Exactly right. Everybody getting that? Subtracted denominator, added numerator. And then if it's a fraction in the denominator, that means it flips. Exactly. Okay, so then last step is just cancel those 8s, and there's our answer. Oh, you might think, let me clear up what might be a misunderstanding. So we have right now log base 5 of 6x minus, 6x minus 1 to the 4th x, right? Like that? That's what we have left. Now, that 4, you might think, can't I just take that 4 and put it in the front? No. You may not take that 4 and slide it in the front. This is our answer right here. Why not? Why can't I put that 4 in there? I thought we could do that with powers. Yeah, I mean, I did it some other times, but can I do it now with the 4? I got a power here again. What's my problem?
It's multiplication with the terms, right?
Yeah. If I move that 4 to the front, it becomes a multiplier for the whole log as if it had been the power for everybody. Is it the power for everybody? No. Just part of it. You see, if that 4 was like this, if that 4 was out here, everybody's power, then yeah, he can become everybody's multiplier. But if he's not everybody's power, you can't put him in the front and make him everybody's multiplier. He's only part of the deal power, so he can't become the multiplier for everybody. That's what the property really says. So that's just it right there. You can't do any more. We're just done right there. All right, guys, this isn't due yet. We got to finish it tomorrow. It'll be due on Wednesday. I'll update Math Excel. This will be due on Wednesday.